Okay. We're back with another day of Nix. So let me just catch you up a little bit on what's happened since I left on the last stream. Essentially nothing, with one caveat. I did do this, so if I go into the terminal, before I had to use Nano, which, to be totally honest, I still don't really know how to use. It seems like escape is the exit in Nano, whereas like I would think that it's like control. Okay. Oh, you just have to hit him at the same time, maybe. Okay. I thought that it would be control, but and apparently it is. I just wasn't hitting him, I guess, at the same time, which is insane actually to think about. But I installed NeoVim, so it wasn't too difficult actually to get NeoVim installed on NixOS. Let me tell you a little bit about how I did it, and then we'll dive back into wherever we left off. So in Nix, the thing is that your system is configured from one file in I think in here. So if I open up this config file, basically, apparently, everything is built from this configuration file. I just didn't want to say file again because of the word association of hearing it too many times. But so I started learning a little bit about how to read Nix. So apparently this, colon indicates a function. So this is like a function with variables, config, and packages. And then the bracket denotes attributes with values. So the attributes are kind of listed, and then they're equal to something. And then it terminates with this semicolon. So you can see like boot.loader.systemmd -boot.enable is equal to true, semicolon. What that really means is that there's an attribute boot with an attribute loader with an attribute systemmd -boot with an attribute enable, and that has value true. So the type of this attribute is true, imports, it's equal to this bracket. Bracket is list, so this is a list of essentially, I want to say that it's any type, but I actually don't know what types are allowed in the list. But the list includes just the hardware configuration. So from a scan that was done when we first loaded it into Nix. And so when you write things in here, you can then call NixOS rebuild with a flag. In the case that I did, I called switch, but you could also do boot, and that tells the system to build from what's in this file. So how easy was it to install NeoVim? All we had to do was put right here in the environment system packages. Well, all we did was include, okay, I actually don't understand the notation. With packages, semicolon, and then packages.neovim. So the with function, or with, the syntax, kind of don't know what it's referring to, but I think it's referring to this thing. Okay, so this is something to figure out too, but it was as easy as just putting packages.neovim. The thing that I don't know about after the fact is, obviously I have a personal configuration for NeoVim on, say, like my main desktop, How am I going to get that enabled on the computer? My laptop? Not totally sure. And I've seen some people do some explanations. I've seen some explanations about like, how people have done it on NixOS. A lot of people essentially want to have a home.config file in their home directory, which is understandable. That's what is used in I think every other version of Linux effectively. But in Nix, it's not so straightforward because the point is that you want to have a reproducible system is what the philosophy is. So we're learning that philosophy, and we're also going to think about whether or not we want to have a reproducible system with our own personal config on NeoVim every time we kind of copy this config file over to another system. So I'm kind of on the fence. I would rather have it so that my individual user can specify their own config files. So each individual user could specify NeoVim. I did think that, yeah, I wanted NeoVim. Personally, I almost felt like it would be like cheaper. I mean, definitely less system resources if I would have just put Vim here, right? So here's Vim. Just instead of Nano. But I figured this is my personal laptop, so no one else should be using it. It's fine if I use NeoVim instead. Alright. So we still have a list. Somewhere. We're still on step 0. We haven't learned Nix, and we're going to read the manual. Things to do: set up secure bootloaders so that the red bar is gone. That's still there. Set wait time. That's still there. Install Vim. I technically installed NeoVim, so there's a little bit of a question mark here. Whether or not I still want to do that. Change desktop environment to Cosmic Alpha. I'm actually starting to get used to GNOME, but I don't want to keep it. I want to switch it to something else, but I just don't know what. And Cosmic would be cool if it was beta. Just a little bit further ahead. There are some things that I kind of want to add to this list. One thing that's been driving me crazy is like my touchpad. When I click on something, like just by tapping, it stays as a click for like 2 seconds. So if I like tap and then move, like it treats that as like a click and drag. And I would rather that be like no seconds at all. I hate that. I'd rather it be like double click as click and drag. Okay. Now I can't reproduce it. Maybe that's because okay, there's like a very small window, but it's big enough where like I routinely am clicking and dragging shit that I don't want to be. So we're gonna figure out if that's a bug or if that's intentional by GNOME. Touchpad. Click time. Between click and hold. Is this a bug? And there was one more thing that I was just thinking. I'm not actually convinced, but I'm curious if my touchscreen will ever work again. So can we get the touchscreen to work? Okay. And that's it. So, back to reading the manual. Let's do Firefox. And okay, Nix.dev. Tutorials, actually. Guides to getting things done, tutorials, my cat. Hi, Cha-Cha. He's just like, okay, I'm gonna, he's like on the laptop. Whoa. He wants to cuddle, but there's no room, and he doesn't consider the laptop keyboard as taking up space because he can lay flat on it. So why would that be space? But it is space. So. I think that honestly these guides are like too advanced for me in a lot of ways. Like what to do if a binary catch is down or unreachable. I think that's referring to if you build something, then how Nix operates, we found out last time, is that it will first try to check if a binary catch is available. So it'll ping like NixOS, Nix.os, or Nix.org, whatever it is, and look up and see if the build that you need has already been compiled, and if it has, then it will just download that. Otherwise, it'll build from source. And so, like, what to do if a binary cache is down or unreachable? I thought the option was like build from source, but maybe that's not the ultimatum. And I think that like I haven't even gotten to like building anything. I've only built Neovim so far, so we can maybe kind of move past that. So there's two things. So one of them is the NixOS manual, and one of them is Nix packages manual. Tutorial sounds actually kind of useful though, right? The tutorial series is where you should start learning Nix. In these lessons, you will use Nix commands to obtain almost any piece of software, create development environments on the fly, and learn how to make reproducible scripts. You will also learn reading the Nix language and later use it to build a portable, reproducible development environment. So we got ad hoc shell environments, reproducible interpreted scripts, declarative shell environments towards reproducibility. This is a weird statement. That you can also share the command invoking such a shell with others, and it will work on all Linux distributions, WSL and Mac OS. Once you, why is that? You can also share the command invoking such a shell. In a Nix shell environment, you can immediately use any package packaged with Nix, any program packaged with Nix. Once you install Nix, you can use it to create new shell environments with programs that you want to use. So I can just run cow say no can do. Use Nix shell, and then so the thing that I'm kind of questioning right now is whether or not so this is the nix.dev, which, right, we're not trying to develop Nix. We are trying to use Nix just for the computer though. I'm tempted to use that first. So where we got last time, was not in any of this. It was it was here. I think my version of Nix is Nix 2.28. And I should be able to, which would be this one also. If we're using the fact that I'm on the, I'm pretty sure I'm on stable. And we got to 4, which was Nix store. I don't think we got past that. It's actually super ridiculous. I don't know. I'm gonna try to show you. He's like not even fully on the desk. But he's trying his best. Okay. I think he won a little bit. So now he's on the desk. Okay, so we read up until Nix store. I kind of am the type that would rather read everything first and then try to experiment and then read everything again, which is not necessarily super effective, especially when there's fucking like this many experimental commands. Yeah, I pretty much just want to read 4, 5, and 6. So we'll start with the Nix store, and then after all of this, we'll see. Look at that, fucking exactly what I was talking about. And this, I just did it again. After doing that, we'll come back to the tutorial. We'll try that, and then we'll actually just go through and start messing with stuff, I think. So the Nix store is an abstraction to store immutable file system data, such as software packages, that can have dependencies on other such data. There are multiple types of Nix stores with different capabilities, such as the default one on the local file system, or binary caches. Nix uses a simplified model of the file system, which consists of file system objects. Every file system object is one of the following. It's either a file, possibly empty sequence of bytes for contents, or a single boolean representing the executable permission. Typically, a file system maintains permission settings for each stored item, commonly files and directories that either grant or deny the ability to manipulate file system items. Often the settings allow controlling access based on functions such as read, change, navigate, and execute, and to different users or groups of users. The fuck is the difference here? Oh. Linux file systems such as X2, X3, X4 support POSIX. And that's all that I think we really need to know. Traditionally, file permissions on a Unix-based file system is defined by POSIX. It specifies 3 classes, user, group, and others, that allow for mapping permissions to users, and 3 operations, read, write, and execute, that can be granted or denied for each class. When a file is created, its permissions default to that as accessible via the unmask command. Oh, umask. In a Unix-based file system, everything is a file, even directories and other special files. Read grants the ability to read a file, write grants the ability to modify a file, execute grants the ability to execute a file. That sounds pretty straightforward, right? Although not, I think, in how you actually implement such a thing, but... Yeah, okay, weird. It's weird that like read, write, and execute all have this, like, you can't do this without write, you can't do this without execute, you can't do this without read. Actually, you can't do this one without execute, and okay, I'm gonna look this up. Multi-finger touchpad taps are way too slow on GON compared to Windows. Tapping with 2 fingers and quickly following with 1 finger drag triggers right-click drag. Tapping with 3 fingers and following with 1 finger drag triggers a middle-click drag. Yeah. I think I might just disable this because it's like annoying. It's also annoying to click though, right? Like, and if I click, I'm still gonna have this issue, right? No, I hate that. I'll just have to be slow. Okay. I just fucking did it. Come on, man. We're gonna get rid of it. Fuck it. Can I undo that? Did not mean to fucking change this setting. Like the scrolling is also way too fast. In GNOME. lib input config, install lib input tools, sudo apt install lib input tools. That's not even gonna work on my OS. Lib input measure touchpad size, get your touchpad dimensions, adjust the scroll factor using a command. You may need to reboot or restart GNOME. Okay, well, we're just gonna go back to this. Oh god, now I have to like, I'm gonna get a finger strain just because of clicking. So where were we in all of this before I got distracted by the file system? Okay, so everything is either a file, a directory, or a symbolic link, which is an arbitrary. A directory is a mapping of names to child file system objects. Mapping of names to child file system objects. Mapping of names. Oh, so you. God, there's so much fucking hair on the table now. So you create like a dictionary or something for files and their names. Great. Or symbolic link, which is an arbitrary string. And then Nix does not assign any semantics to symbolic links. So in computing, a symbolic link is a file whose purpose is to point to a file or directory by specifying a path. Okay. I'm gonna lose it.
Sorry, me?
No, just fucking so tired. So what's the purpose of a symbolic link? So programs that read or write files named by a symbolic link will behave as if operating directly on the target file. However, they have the effect of changing an otherwise hierarchic file system from a tree into a directed graph, which can have consequences for such simple operations as determining the current directory of a process. Even the Unix standard for navigating a directory's parent directory no longer works reliably in the face of symbolic links. Some shells heuristically try to uphold the illusion of a tree-shaped hierarchy, but when they do, this causes them to produce different results from other programs that manipulate path names without such heuristic, relying on the operating system instead. Programs that need to handle symbolic links specially thus need to identify and manipulate them directly. Some Unix as well as Linux distributions use symbolic links extensively in an effort to reorder the file system hierarchy. This is accomplished with several mechanisms such as variant context-dependent symbolic links. This offers the opportunity to create a more intuitive or application-specific directory tree and to reorganize the system without having to redesign the core set of system functions and utilities. Symbolic links are automatically resolved by the file system. Any software program, upon accessing a symbolic link, see the target instead. The program is aware if symbolic links or not. Shortcuts are treated like ordinary files. Folder shortcuts. Okay. I don't have any idea. I mean, I get maybe to some extent. Oh shit. I missed the chat. Lib input has Nix options. I don't think you're reading chat. I'm just gonna watch how your journey goes with Nix. Thanks, man. Symlinks are like shortcuts on Windows, but way more powerful. NTFS doesn't have symlink features. NTFS doesn't have symlink features. NTFS is the file system that Windows uses. But Unix files systems like ext4 have this feature. But Unix file systems like ext4. Symlinks are like shortcuts on Windows, but way more powerful. NTFS doesn't have symlinks features, but Unix file systems have this. Thanks. Sorry that I missed that. I have to like somehow shift my view from the laptop up. Yo. So I was actually in this and then clicked out because I got distracted. File system objects and their children form a tree. A bearer file or similar can be a root file system object. Thanks. I'll take it up. I'll take you up on that if I get stuck anywhere. I'm planning on spending like, you know, a month or more trying to just learn it for a while before getting into really trying to mess. I mean, okay, I'm not going to spend a whole month without messing with anything, but I imagine that it's going to take a little bit of time. Just reading so far, it feels like that at least. So file system objects and their children form a tree. A bare file or symlink can be a root. File system objects. Nix does not encode any other file system notions such as hard links, permissions, timestamps, or other metadata. Examples of file system objects. A plain file, 50 bytes, executable, false. An executable file, executable, true. Symlink, user bin, shell. A directory with contents, bin, hello. Executable, true. Share, info, hello. Executable, false. Man1, hello. A directory that contains a symlink and other directories, bin, share, go bin. Nix support, share. Okay. For many operations, Nix needs to calculate a content address of a file system object. Usually this is needed as part of content addressing store objects. Since store objects, content addressing store objects. Since store objects always have a root file system object, usually this is needed as part of content addressing store objects. Store objects always have a root file system object. Some command line utilities also just work on raw file system objects, not part of any store object. Every content addressing scheme Nix uses ultimately involves feeding data into a hash function and getting back an opaque fixed size digest, which is deemed a content address. Various methods of content addressing thus differ in how abstract data, in this case a file system object and its descendants, are fed into the hash function. Okay. Serializing file system objects. So the simplest method is to serialize the entire file system object tree into a single binary string, and then hash that binary string, yielding the content address. That sounds pretty reasonable. That one seems the most reasonable. In this section, we describe the currently supported methods of serializing file system objects. So there's flat serialization. A single file object can just be hashed by its contents. This is not enough information to encode the fact that the file system object is a file. But if we already know that the file system object is a single non-executable file by other means, it's sufficient. A single file object can just be hashed by its contents. I guess two file system objects can never share the same contents unless they. I mean, I guess they wouldn't. But I don't know what the contents of a file, I guess, would be. Because the hash data is just the raw file, as is, this choice is good for compatibility with other systems. For example, Unix commands like SHA-256-SUM or SHA-1-SUM will produce hashes for single files that match this. Okay, another one, NixArchive. For the other cases like file system objects, especially directories with arbitrary descendants, we need a more complex serialization format. Examples of such serializations are the zip and tar file formats. Okay. However, for our purposes, these formats have two problems. They do not have a canonical serialization, meaning that given a file system object, there can be many different serializations. For instance, tar files can have variable amounts of padding between archive members. Tar files can have variable amounts of padding between archive members, and some archive formats leave the order of directory entries undefined. This would be bad because we use serialization to compute cryptographic hashes over the system objects, and for those hashes to be useful as a content address or for integrity checking, uniqueness is crucial. Otherwise, correct hashes would report false mismatches, and the store would fail to find the content. Right. Okay, they store more information than we have in our notion of file system objects, such as timestamps. This can cause file system objects that Nix should consider equal to hash to different values on different machines, right? Just because the dates differ. As a practical consideration, the tar format is the only truly universal format in the Unix environment. There's many problems, such as inability to deal with long file names and files larger than 2 to 33 bytes, which is a lot, right? I kind of just want to check. It's not that much. Current implementations such as GNU tar work around these limitations in various ways. Okay. For these reasons, Nix has its very own archive format, the NixArchive format, which is carefully designed to avoid the problems described above. The exact specification of the NixArchive format is specified somewhere else. It's fine. Content addressing file system objects beyond a single serialization pass. Serializing the entire tree and then hashing that binary string is not the only option for content addressing, however. Another technique is that of a Merkle graph, where previously computed hashes are included in subsequent byte strings to be hashed. I kind of thought this was like the Bitcoin thing. Merkle tree. I mean, okay. I'm not gonna, the blockchain, I'm not gonna look it up, but okay, I'm like tempted. It's a tree in which every leaf is labeled with a cryptographic hash of a data block, and every node that is not a leaf is labeled with the cryptographic hash of the labels of its child nodes. Every leaf or node is labeled with the cryptographic hash of a data block. And every node that is not a leaf, called a branch or an internode, is labeled with the cryptographic hash of the labels of its child node. It's, yeah, I guess, okay. I would never consider the arrows to go this way for some reason, but I guess it makes sense. This one refers to this one. And so this one is hashing the children. And this one hashes child, and this one hashes child. But they each contain maybe their own hash also. I don't know. Hash tree is a generalization of hash list or a hash chain. Okie doke. In particular, the Merkle graphs can match the original graph structure of file system objects. we can first hash serialized child file system objects, and then hash parent objects using the hashes of their children in the serialization of the parent file system objects. Currently, there's one such Merkle DAG content addressing method supported. Okay. And then there's get, which is experimental. This method is part of the get hashing experimental feature. Get's file system model is very close to NixOS, and so get's content addressing method is a pretty good fit. Just as with regular get, files and symlinks are hashed as get blobs and directories are hashed as get trees. Okay, I'm not going to worry about the experiments for the moment. Okay. The actual Nix store, right? So a Nix store is a collection of store objects with references between them. A store object consists of a file system object and a set of store paths as references to other store objects. Store objects are immutable. Once created, they do not change until they are deleted. Once created, they do not change until they are deleted. Just like file system objects, store objects can also be content addressed unless they are input addressed. For store objects, the content address we produce will take the form of a store path rather than a regular hash. In particular, the content addressing scheme will ensure that the digest of the store path is solely computed from the Okay, it's going to be solely computed from the file system object graph, the root one and its children, if it has any. The file system object graph, the root one and its children, if it has any. References, store directory, and name of the store object, and not any other information which would not be an intrinsic property of the store object. Okay. The file system object graph. I guess the thing that the thing that's tripping me up a little bit about it is also just the name of store. I guess it's because you're like stowing it away or storing it in somewhere, maybe. Not so much as, or maybe it is because you're like going out and getting it, but I always imagine that this is not a local thing, even though I think that it is. So for the full specification of the algorithms involved, see the specification of store path digest. Don't think it's so important to know how it's specified right now. Content addressing each part of a store object. With all currently supported store object content addressing methods, the file system object is always content addressed first, and then that hash is incorporated into content address computation for the store object. The store is literally a path in my like root directory, right? Yeah. It just feels like, like, I don't know, like you go to the store to download something from the web, or that's just coming from like Windows. This is how I feel. So we did go over content addressing file system objects. And I guess okay. I think I'm like putting it together, but I think that the content address is like right, like whether it's a file or a directory or a symlink. Also, is it executable, read write, and there's another one. I guess what it contains, its file size, things like this. But actually addressing it, okay, is special. And then that hash is incorporated into content address computation for the store object. And then one thing that's important I have to also think about like what is needed to be like store, like what is needed to be a store object. Like if I was on a different, okay, so I guess part of this is just like, I think because this is the operating system, and I can't disentangle that from, to some extent, like the rest of my system. My windowing manager, file manager, it's sometimes a little bit difficult, I think, to recognize what is and is not like innately part of the system. So if I have, for example, in my home directory of filed notes, this is not something that, like, if I took my Nix config, put it somewhere else, then it rebuilds with that notes file in the home directory, right? With all currently supported store object content addressing methods. That makes sense. Okay, so references to other store objects. So with all currently supported store object content addressing methods, other objects are referred to by their regular string encoded store paths. Self-references. Other objects in the store, other store objects are referred to by their regular store paths, maybe. Self-references. Self-references, however, cannot be referred to by their path because we are in the midst of describing how to compute the path. Okay. The alternative would require finding as hash function fixed point, a hash function fixed point, i.e. the solution to an equation of the form digest is hash of some other thing, which is computationally feasible, blah, blah, blah. It's believable. Instead, we have has self-reference boolean, which ends up affecting the digest. In all currently supported store object content addressing methods, when hashing the file system object data, any occurrence of a store object's own store path in the digested data is replaced with a sentinel value. The hashes of these modified input streams are used instead. When validating the content address of a store object after the fact, the above process works as written. However, when first creating the store object, we don't know the store object's store path, as just explained above. We therefore, strictly speaking, do not know what value we will be replacing with the sentinel value in the inputs hash functions. What instead happens is that the provisional store object, the data from which we wish to create a store object, is paired with a provisional scratch store path. That provisional store path is instead what is replaced with the sentinel value, rather than the final store object, which we don't know yet. Okay, so there's some self-referencing files that have to be taken into account. It is an informal property of content address store objects that the choice of provisional store path shouldn't matter. In other words, a provisional store object is prepared in the same way except for the choice of provision store path. Provisional data need not be identical. Okay. Name and store directory. These two items affect the digest in a way that is standard for store path digest computations and not specific to content addressing. Consult the specification of store path digests. Content addressing methods. For historical reasons, we don't support all features in all combinations. Each currently supported method of content addressing chooses a single method of file system object hashing and may offer some restrictions on references. Names and store directories are unrestricted. Okay, there's flat. This uses the corresponding flat method of file system object content addressing. References are not supported. Store objects with flat hashing and references cannot be created. Okay. Text. This also uses the corresponding flat method of file system object content addressing. References to other store objects are supported, but self-references are not. This is the only store object content addressing method that is not named identically with a corresponding file system object method. It is somewhat obscure. And then Nix archive. This uses the corresponding thing. References are supported so long as the hash algorithm is SHA-256, but not neither kind otherwise. And then Git. Just experimental. Example. Okay. Okay, so we have a rendered store path, Nix store hash, and then Git 2.38.1. Nix implements references to store objects as store paths. Think of a store path as an opaque unique identifier. The only way to obtain the store path is by adding or building store objects. store path will always reference exactly one store object. Store paths are pairs of 20 byte digest for identification, a symbolic name for people to read. So the digest is that, and the Firefox is what's appended at the end. To make store objects accessible to operating system processes, stores have to expose store objects through the file system. Store path is rendered to a file system path as the concatenation. Okay, yeah, it's rendered to the file system path as concatenation of store directory. Typically, NixStore. Store directory, yeah, which is NixStore, which is where mine is too. And then path separator, then the digest hyphen name. And base 32. Okay, I didn't expect that. 20 arbitrary bytes become 32 ASCII characters. And 20 arbitrary bytes become 32 ASCII characters. Okay. This is not the same though, right? 32 choices of ASCII characters, unless they're limited. Base 32 is an encoding method based on the base 32 numeral system. It uses an alphabet of 32 digits, each of which represents a different combination of 5 bits. Which ones are not included? A, B, C, D, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S, T, U, V, W, X, Y, and Z, and then 2, 3, 4, 5, 6, 7. So 0, 1, 8, and 9 are not included. There's like a 0 here though, unless that's an O. Yep. But I'm just kind of curious because I thought that LSCD LSCD store ls. I thought that there are like zeros in here, yeah. And there's also ones. Yeah, so I don't think it's totally true. Or if it is, then it's maybe not. It's maybe not. I don't know. It's maybe not so direct. Custom variant, yeah, okay. So exactly how the digest is calculated depends on the type of store path. Store path digests are supposed to be opaque. And so for most operations, it is not necessary to know the details. That said, the manual has a full specification of store path digests. Right, which we could read at some point. I'm kind of curious. Just, it was in, because I didn't hit control. So, section 5.1. I wonder if this is like a large thesis for computer science also. I mean, it's pretty big. 281 pages. I don't know. To some extent, I mean, like, to some extent, it looks like kind of totally new. So in math, that would be like, this would be like a huge, huge thesis, honestly. Yeah. Dolstra. I just know the last name, because there's another name that I heard the other day in computer science, which is like Dijkstra, but that sounds kind of wrong. But similar in some ways. This is like really not important, so I'll probably stop doing it at some point. I just wanted to know like what the word set was for the hash. And I could probably figure it out. My background's math. So, oh, like here, it actually says it. The set of digits is this. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, D, skip E, skip O, skip U, and skip T. And then the rest of the alphabet. This is to reduce the possibility that hash representations contain character sequences that are potentially offensive. Which is that's kind of crazy. I wonder, I don't know. Like you could have accidentally hashed the word like fuck or something. If you included you. Yeah, I think it's interesting. Okay, anyways. Okay, so there's no E's, there's no O's, there's no U's, and there's no T's. And that one's like recognizable. Okay. Like yeah. That one's believable. Okay. Okay, anyways. Fingerprint. Fingerprint is fingerprint equals type SHA-256 inner digest store then name. Note that it includes the location of the store as well as the name to make sure that changes to either of those are reflected in the hash. The type is one of text. This is for the text method of content addressing store objects. The optional trailing store paths are the references of the store object. source, store path, self. This is the Nix archive method of content addressing store objects. If the hash is SHA-256, just like in the text case, we can have the store objects referenced by their paths. Additionally, we can have an optional self label to denote self-reference. Then output ID. For either the outputs built from derivations or content address store objects that are not using one of the two above cases. To be explicit about the latter, that is currently these methods: flat, get, nix, archive, ID, inner fingerprint, one of the following based on type. Okay, a little historical note. The original reason for this, okay, the type and type, so source and output out, grammars technically overlap in purpose in that both can represent data hashed by its SHA-256 serialization. The original reason for this was this way of computing names was to prevent name collisions. For instance, the thinking was that it shouldn't be feasible to come up with a derivation whose output path collides with the path for a copied source. The former would have an inner fingerprint starting with output out, while the latter would have an inner fingerprint starting with source. Since this thing, 2008, however, it was decided that separating derivation produced versus manually hashed content addressed data like this was not useful. Now data that is content addressed with SHA-256 always uses the source construction regardless of how it was produced. Okay. I'm probably gonna... Oh wait, I skipped some amount. Okay, so we still need to figure out what a store derivation is. And then how we derive the path is not so important in my mind, just that there is a scheme for path derivation, I guess. Okay, so let's figure out what... Okay, let's figure out what a derivation is. Besides functioning as a content-addressed store, the Nix store layer works as a build system. I've been kind of curious about this, but build system is a generic term for software that facilitates the building of software by automating the invocation of compilers, linkers, and other tools. Nix can be used as a generic build system and has no knowledge of any particular programming language or toolchain. Okay. Other systems like Git or IPFS also store and transfer immutable data, but they don't concern themselves with how the data was created. Nix cares about this. So derivations represent individual build steps, and deriving paths are needed to refer to the outputs of those build steps before they are built. Okay. So before you can actually build something, you have to be able to calculate the path in order to refer to the output. Store derivation, I think. Store derivation. Derivation is a specification for running an executable. Derivation is a specification for running an executable on precisely defined input to produce on more store objects. For running an executable and precisely defined input to produce maybe one or more store objects. To produce more store objects. These store objects are known as the derivation's outputs. Derivations are built, in which case the process is spawned according to the spec. And when it exits, required to leave behind files which will, after post-processing, become the outputs of the derivation. This process is described in detail in building. A derivation consists of a name, an input specification, which is also a set of deriving paths, an output specification, which specifies which output should be produced, and a bunch of metadata. The system type, it's like x86, 64, where the executable is to run. And the process creation fields to spawn the arbitrary processes which will perform the build step. Referencing derivations. Derivations are always referred to by the store path of the store object they are encoded to. See the encoding section for more details on how this encoding works, and thus what exactly, exactly what store path we would end up with for a given derivation. Store path of the store object which encodes a derivation is called a derivation path. Okay. Deriving paths. Oh, I thought I turned that off. Deriving paths are a way to refer to store objects that may or may not yet be realized. Deriving paths are a way to refer to store objects that may or may not be realized yet. There are two forms. Constant, just a store path. It can be made valid by copying it into the store from the evaluator command line interface or another store. Output, a pair of a store path to a store derivation. Okay. Or output, a pair of a store path to a store derivation and an output name. Okay, in pseudocode you have like type output name equals string, type constant path equals path store path, type out path. Deriving paths are necessary because, in general and particularly for content addressing derivations, the store path of an output is not known in advance. We can use an output deriving path to refer to such an output instead of the store path, which we don't know yet. Parts of a derivation. A derivation is constructed from the parts documented in the following subsections. Inputs are a set of deriving paths referring to all store objects needed in order to perform this build step. Process creation fields will presumably include many store paths. The path to the executable normally starts with a store path. The arguments and environment variables likely contain many more store paths. Rather than somehow scanning all the other fields for inputs, Nix requires that all inputs be explicitly collected in the inputs field. It is instead the responsibility of the creator of a derivation to ensure that every store object referenced in another field is included in this inputs field. The system type on which the builder executable is meant to run. The system type on which... Okay, system is the system type on... Necessary condition for Nix to schedule a given derivation on some Nix instance is for the system of that derivation to match that instance's system configuration option or extra platforms configuration option. By putting the system in each derivation, Nix allows heterogeneous build plans where not all steps can be run on the same machine or same sort of machine. Nix can schedule builds such that it automatically builds on other platforms by forwarding build requests to other Nix instances. Process creation fields. These are the 3 fields which describe how to spawn the process which will perform the build. You may note that this has everything needed for an exec v call, system call. This is the path to an executable that will perform the build and produce the outputs. There's arguments. Command line arguments to be passed to the builder executable. Note that these are the arguments after the first argument. First argument passed to the builder will be the value of builder as per the usual conventional Unix. Environment variables which will be passed to the builder executable. Placeholders are opaque values used within the process creation fields to store objects for which we don't yet know store paths. There are strings in the form /# that are embedded anywhere within the strings of those fields, and we are considering to add store path like placeholders. Okay, so I guess, you know, I have to think about like which problem we're trying to solve. But in this case, I mean, there's a bunch of problems that you have to solve, I guess, when you have to start everything over again. But a huge one is just, I mean, I'm not gonna say it, but well, I will. Okay, a huge one is just this is what the whole thing has been saying this whole time to me is like, okay, you want to try to execute something. You need to know where the binaries are, but let's say you kind of like haven't generated that folder yet, or the store path. Then how are you supposed to get the location where the binaries are going to go? Something along these lines. When especially the path's name is supposed to be hashed based off of its contents. I don't know. There's also huge cognitive dissonance here between me and this section in particular. I think because my background in computer science is like non-existent. So to some extent, like building, for example, is totally opaque to me. Like what that means in terms of, like you could say screen to output. What that means is kind of not clear. So I'm not going to read all of this. I think is the easiest thing to do. How far did we get? Store derivation and deriving path. Derivation outputs and types of derivations. Content addressing derivation outputs. Input addressing derivation outputs. And building and then store types. Like store types is probably too much for me. It's a good question. What's my goal? My original goal was to put Linux on my computer to have fun. And then I started reading a little bit about Nix through the manual, and I thought, okay, I'm actually learning kind of a lot about just in general. Maybe more about even just like Linux or how operating systems exist. And so now my goal is just I'm gonna try to learn some amount of computer science from, I guess, this experience with Nix. And I guess I don't have a direct goal, but for now, I guess, where do I want to get to? That's a good question. What got you into Nix? I'm curious what the standard, experience is. I kind of know someone who got into Linux a couple years ago, one of my supervisors, and he said that he got convinced to use NixOS from the YouTube internet propaganda, and he said he was reading the Dolstra's thesis and he thought it was pretty cool. So I kind of got swayed by this, not gonna lie, a little bit. And it is cool. I mean, it's totally different than it sounds totally different than anything that I've experienced before. But okay, this one though we probably will actually need to read, I think, just because of knowing what the A-term format is, or JSON. Okay, let me try to see. So there are two formats documented separately: legacy A-term format and experimental, currently under development and changing JSON format. Every derivation has a canonical choice of encoding used to serialize it to a store object. This ensures that there is a canonical store path used to refer to the derivation. Yeah, it's neat that you have one it is neat that you have one config file and that you just can specify the things that you want and then your system builds. I mean, that aspect of just using a computer feels totally different. So in the common case, the inputs to store objects are either constant deriving paths. For content addressed source objects, which are initial inputs. I've heard, okay, so I've heard that Nix is used commonly on, I don't know if it's common, but I've heard that it's used on servers because of the reproducibility. That's at least what the Wikipedia says, right? Okay. So what is the choice that I'm going to make here? Okay, so explanation. In general, we need to realize a store object in order to be sure to have a store object for it. But for these two cases, this is either impossible or impractical. In the output case, this is impossible because we cannot build the output until we have a correct derivation. And we cannot have a correct derivation until we have the output path. In the input case, this is impractical. If we always build a dependency first, and then refer to its output by the store path, we would lose the ability for a derivation graph to describe an entire build plan consisting of multiple build steps. Encoding. So derivation, there are two formats, legacy and experimental. Every derivation has a canonical choice of encoding used to serialize it to a store object. This ensures that there is a canonical store path used to refer to the derivation. As described in referencing. So currently the canonical encoding for every derivation is the A term. But this is subject to change for types of derivations which are not yet stable. Regardless of the format used when serializing a derivation to a store object, that store object will be content addressed. In the common case, the inputs to store objects are either constant deriving paths or the outputs of other derivations. Constant deriving paths are encoded simply as the underlying store path is. Thus, we see that every encoded store path is also a valid encoded constant deriving path. Okay, or output. So output deriving paths are encoded by encoding of a store path referring to a derivation, or caret separator, or an exclamation point, the name of an output of the previously referred derivation. So an example. So here's deriv out. Output deriving paths. So Nix store, usual encoding up to here, and then output name. Note the .drv. So far we've used store paths to refer to derivations. That works because we've implicitly assumed that all derivations are created statically, created by some mechanism out of a band, and then manually inserted into the store. But what if derivations could also be created dynamically? In other words, what if derivations could be the outputs of other derivations? In the parlance of build systems a la carte, we're generalizing the Nix store layer to be a monadic instead of a applicative build system. How should we refer to such derivations? A deriving path works the same as how we refer to the other derivation outputs. But what about a dynamic derivations output? For that, we need to generalize the definition of deriving path, replacing the store path used to refer to the derivation with a nested deriving path. Okay, this is where I want to get to for the time being. The encoding is adjusted in the natural way, encoding the DRV field recursively using the same deriving path encoding. The result of this is that it is possible to have a chain of output name at the end of the final string as opposed to just a single one. Okay. Okay, let me go to building just to see what this is about. Normalizing derivation inputs. Each input must be realized prior to building the derivation in question. Once this is done, the derivation is normalized, replacing each input driving path with its store path, which we now know from realizing the input. Builder execution. The builder is executed as follows. A temporary directory is created under the directory specified by tempdirect. Defaults to temp, where the build will take place. Current directory is changed to this directory. The environment is cleared and set to the derivation attributes as specified above. In addition, the following variables are set. Nix build top contains the path of the temporary directory for this build. Also temp direct, tmp dir, temp dir, tmp and temp are set to point to the temp directory. This is to prevent the builder from accidentally writing temporary files anywhere else. Doing so might cause interference by other processes. Path is set to path not set. Path is set to path not set to prevent shells from initializing to their built-in default value. Home is set to homeless shelter to prevent programs from using etc. Pass WD or the like to find the user's home directory, which could cause impurity. Usually when home is set, it is used as the location of the home directory, even if it points to a non-existent path. NixStore is set to the path of the top level NixStore directory. Nix attributes JSON file and Nix attributes shell file. If structured attributes is set to true for the derivation. Detailed explanation of this behavior can be found in some other section. For each output declared in outputs, the corresponding environment variable is set to point to the intended path in the Nix store for that output. Each output path is a concatenation of the cryptographic hash, the name, and the output name. Name attribute and the output name. If any output path already exists, it's removed. Also, locks are required to prevent multiple Nix instances from performing the same build at the same time. A log of the combined standard output and error is written. The builder is executed with arguments specified by the attribute args. If it exits with exit code 0, it is considered to have succeeded. The temporary directory is then removed. If the builder exited successfully, the following steps happen. In order to return the output directories left behind by the builder into proper store objects. Normalize the file permissions. Nix sets the last modified timestamp on all files and the build result to 1. Sets the group to default group and sets the mode of the file to 0444 or 0555. Read only with execute permissions enabled if the file was originally executable. Any possible set UID and set GID bits are cleared. Calculate the references. Nix scans each output path for references to input paths by looking for the hash parts of the input paths. Since these are potential runtime dependencies, Nix registers them as dependencies of the output paths. Nix also scans for the references to other outputs paths in the same way. Because outputs are allowed to refer to each other, if the outputs references to each other form a cycle, this is an error. That's great. Because the references of store objects must be acyclic. So we get some big acyclic graph at the end of the day. Which is just a tree, right? I mean... Okay, store types. I'm not going to think too much about this. Experimental SSH store, HTTP binary cache store, SSH store. We're going to go just into the Nix language, which is probably where I should have been, like from the get-go. But I think that I'm going to have to start here another time, just because it's getting a little bit late, and I did promise my partner that we would go play soccer at 6:30 before the sun goes down too far. So HRF dude, thanks for tuning in, and maybe I'll see you around for chapter 5. Thanks for coming. You too. Have a good day. Peace.